All right, hey everybody. Welcome back for those of you who are coming back from the first two installments, and welcome any newcomers. We are continuing our Enterprise Node kind of webinar series. Tonight's going to be talking about securing your environment. So previously we talked about code quality. We also talked about code discovery, which are two very important things to concern yourself with in an enterprise environment. But now we're going to get a little bit deeper into securing your entire environment from top to bottom. So a little bit of background before we get started. About me, I'm a tech lead at Major League Soccer. My name is Curtis Kemple. You can find me on Medium, Twitter, GitHub, all the usual places. I've been with Major League Soccer for coming up on a year now. It's been a great experience there. It's really eye-opening, even more so into the world of enterprise. We have a large amount of JavaScript in our infrastructure, so we run about 20-ish node services. We have, X number of, public and private NPM modules, and just basically a ton of code for internal tooling and monitoring and just, lots of JavaScript. So a lot of these things that I'm talking about are things that we use to speed up our velocity or to make the applications that we write more secure. And that's what our focus is going to be on mainly today. A lot of the examples in this webinar are actually pulled from this repository. It's called Awesome Enterprise Web Service, and it's basically a culmination of all the pieces of the things we've been going over. So the last two webinars, we stayed very high level. It was more about patterns and best practices. We did talk about the tools to how to accomplish some of those things, but we never looked at implementation. Although we won't be diving too deep into it, we will be looking at some code samples today when we start talking about securing our applications. So real quick, before we get started, we could take a minute to think about this. And then also there are two polls that I would like everyone to fill out if they don't mind. So those two polls are basically just how much experience you have with JavaScript, and really what does enterprise JavaScript mean to you when you hear that phrase? And then save that last poll for the end. So when we talk about securing our environment and why it's important, I mean, there's a couple obvious things that come to mind, right? Like, security, right? But like, what does security mean? What are we actually defending from? What are some of the common problems that you face securing a node environment as opposed to other environments? And what are some of the resources and things available to you to help you do this better? So some of the benefits of securing your environment, obviously, is it protects your company from potential threats. I mean, pretty much not a day goes by where we're not hearing about somebody being hacked. And now, the latest trend now is like ditch passwords. Passwords are unsafe. Send email links instead, right? Like passwordless auth is becoming the hot new thing. And and you're always hearing about companies losing personal data, or you get an email from LinkedIn and they tell you to update your password because or it could be any site. So it definitely helps to protect your company from potential threats. So that's the number one. The second one, and this is something that isn't really spoken out loud, but internally to stakeholders and to the developers, it helps improve the confidence in the code and systems. And the more confident people are in what you're building, obviously, the better job, one, that they think you're doing. And two, it opens up room for you to suggest more things, right? So the more confident we can make stakeholders in the applications that we build and the way that we architect and handle workflow processes, the more confident we become, the more freedom we gain in those processes, right? They start to trust you more. And so this helps go a long way with that. And then thirdly, this is an issue for enterprise, right? So sometimes depending on, and not even just enterprise, right? So this could affect startups as well. Really at the end of the day, you just see this a lot more at enterprise scale, is it helps you meet legal and organizational regulations. So you might have certain security criteria you have to meet as a financial company for your software, and a lot of the steps and practices that we're going to discuss in this webinar will actually help you meet a lot of these organizational and legal regulations. As a matter of fact, I worked for a company that handles over $1 billion a year of through money. So it's not money that is paid directly to us, but because we were hooked up to clients' accounts and then other clients' bank accounts. So basically we were connecting payments through them, not like a PayPal or something like that. This was actually for one end was providing a service, the other end was using the service, and then they would have to pay for that service, and it was easier to automate it through us. But because we had so much money flowing through us and information to so much, or access to so much private and vital information, high security risk information, we had a ton of regulations that we had to meet. So when we were first audited, the news was like devastating. There was a lot of things we had to fix, but it really helped me on a personal level, like as a developer, understand some of the higher level ideas behind security and some easy ways to enable a lot of really awesome security features without really getting in the way of your application. And that's key. So the first thing that we're going to talk about, there's many ways to secure your environment. So first of all, let's talk about what is an environment. So the environment is the entire encapsulation of operating systems, software, dependencies, network connections, everything that your application actually needs to run in a production environment. So that's not just the code. That's not just the API that you start up. It's not, just the operating system you're on. There's many levels. And so what we're going to talk about right now is securing your runtime. And so for those of you who don't have too much JavaScript experience, the runtime is actually where your JavaScript code is ran. So in Node, that's the Node runtime. So it's actually a process that is running and executing your JavaScript code. In the browser, you have different runtimes for different browsers, but point being is that is where your JavaScript is running. So it's important to make sure that your runtime is secure. So we're going to talk a little bit about handling that. So the first way to secure your environment is Node has started releasing long-term support versions. And so what this means is they're actually going to release versions that they will maintain for X amount of time, that will be actively developed and then freeze development and go into a maintenance mode. While in this maintenance mode, there will only be certain changes made. We'll talk more about that in a second. But the reason that they're great is they offer a solid foundation to build apps on. You know exactly how long you have before the next version of the long-term support node is coming. And we'll talk also more about that. And it gives you some great ground room to say, okay, we don't have to worry about any new features coming into this version of Node. We can work on this version and know that the only things that we're going to get are bug fixes and critical security fixes. So it's really great because if you've been in Node for a while, you know that there was a time when it started to get pretty stagnant and it was actually moving extremely slow. We made it up to version 0.12, and some people had enough of it, and there was actually a split. There was a fork where Node and IO.js kind of forked. IO.js started taking off and adding more and more modern JavaScript features and support, and eventually they were merged back together. So you have all this craziness, but now you have official Node also moving fast, and so like it really put Node in a rough position for a little while. It was very rocky ground. So getting these long-term support versions was like a real godsend to people who had already picked Node for big business critical solutions. So if we take a look, this here is the Node.js long-term support release schedule. So the current active LTS right now, so if we look, this chart is broken down by every 6 months, right? Pretty much. So it starts that October, April pattern there at about August of 2015. They threw that extra one in there for October. Yeah. But you can see that the active LTS that we're on is version 4. But if you look in October 2016, we're already going to be at the active LTS version of Node version 6. So Node version 6 is under active development currently. They are adding support for more features, but they plan to finalize that and freeze feature development in October, at which case it will then go into maintenance mode, and then they offer you a nice buffer of October to April to migrate Node version 4 to Node version 6. So if you see the overlap in the blue for the active LTS for Node version 4 and Node version 6. So this is now creating a very secure platform for you to work with, right? It gives you ample time to migrate. It's a steady release pattern. It's enough time that it's innovative and you're getting features, but it's not enough time that you're not falling 6 versions behind, because that in and of itself is a nightmare to deal with. I don't know if anybody's upgraded a project. Like I just upgraded our Apple TV project from Node 0.10 to 6, version 6. That was quite interesting. So the next thing we're going to talk about for securing the runtime is called NSolid. So there's a company called NodeSource, and they offer enterprise node tooling and support. So basically, it's like having high-level Node.js developers, basically, a support ticket away. And then on the reverse side of that, they offer some tools to help you. So one of the tools that they offer is called NSolid. And what it is, it's a complete enterprise runtime. So you're running NSolid instead of running Node. So it's their own runtime that they've put a bunch of security fixes into and closed up a bunch of vulnerabilities and issues. And their main focus was to provide a runtime to enterprise that you had more control over, more access into the processes, things like that. So like I said, one of the biggest features is it enables deep performance insights, like one-click flame graphs, really high-level visualizations about the current state of all your Node applications. But then you can also get pretty granular, and it's all real-time and pretty performant. It's a good solution. You pair something like NSolid runtime with, like New Relic, and you'll have top to bottom monitoring coming from client requests all the way down to how long it's taking particular functions to execute. So it just provides a great level of insight into the core node process that you're running. It also has a CLI tool, right? So it's CLI enabled, which makes it really easy to deploy, set up, and run NodeSolid in an enterprise or production environment, which makes it very friendly. And also, much like Node, which you download and install, they also have their own Docker containers. So like there's the official Node Docker containers, there's official NSolid Docker containers. So if you are already running in Docker, it's literally just changing the from line in your Docker container. And if you're not, it should run seamlessly. You should not see any issues switching from Node to NSolid. It also has an advanced console. So we talked about that a little bit, but one of the other things that we didn't really talk about was you can actually select certain nodes, dig down, get heap shots, and just like analyze your code at a very low level. So you could take like these heap dumps and actually put them into Chrome DevTools profiler and break your JavaScript execution time down that way. And then again, like I said, they also have their own internal like process and performance management analytics. And the other great thing is they have alerting through threshold monitoring. So if you have processes that are starting to eat up too much CPU or too much memory, you can set a threshold for them, and then so you can have this alert, go to Slack or email or whatever, and you can also configure it to attach a bunch of information like those heap dumps I was talking about, and a lot of other things that you can do. So for the next slide, I figured NSolid is a very important product, and I didn't want to spend too much time talking about it, and I figured the best source is the horse's mouth. So the next slide actually just has a minute and like 35-second video about NSolid. So I just wanted to prepare everybody for that because it's going to start playing a video on the next slide. All right, so that was like a quick overview. That last thing that they showed there at the end that looked almost like a bar chart, that was another style of visualization for looking at what's called a flame graph, which is essentially showing you where your process is, like where it in the call stack you're actually spending your time. And I just added this following graph because I want to show this is another version of it that they show, and they didn't really break it out much. And so you can see that they basically break it down, and I don't know if you can see it well on the right, but it literally is showing you every object. You can investigate every object from that heap dump, see all the constructors, all different kinds of ways, see which methods are hanging or taking a long time to process. It's just a really powerful solution. And the cool thing is it's drop-in. So that's what really makes it a lot more beneficial, not to mention that this is going to help you meet security regulations. So another way to secure your environment, aside from even NSolid or an advanced runtime, is containerization. So just by putting our application into Docker, now we're not going to get too deep into like the hardcores of security because obviously every type of software has its issues, but by putting applications into containers, we do gain some benefits, right? So the first one is it boxes up your application and all of its dependencies, the operating system, anything that it needs to run, including the application, is packaged in this little box. So not only can, nothing really get in, but nothing can get out. And so what that gives you is it provides a layer of abstraction from the server. So in the world where maybe, processes are running together on virtual machines, you can actually have issues with files trying to be written to the same place, or, cross-process issues, people installing malicious software on servers, trying to gain access to your processes. And this just adds a few more layers of abstraction for them to try and dig through to get to your actual application process. And it also provides isolation from other applications, right? So it makes it very easy to run X number of X type of applications all on the same server. Which is great. That's another level of security. You don't have to worry about a lot of issues that you could face when having to do different things like that. It's also setting limits on their resources. So workers that are eating up a lot of CPU or a lot of memory are less likely to affect your application. And so that's a layer of security that not a lot of people really discuss. And that's fighting for resources. So in a world where everything is virtual, eventually somewhere there's actual hardware, there's actual CPU, and there's actual RAM. And those have a limited amount of capabilities. And if we're not using software or some other metric to load balance these applications, you can have a process eat up all the memory, and then that can actually bring down other processes. So isolating it and putting it in a container, you can actually provide it faux resources, right? So it thinks it has X amount of CPU and X amount of memory, but if it really eats up all that's available to it, it's a virtual CPU and virtual memory. You're a lot less likely to see a CPU be eaten up from containerized applications. However, it does still happen. And it's actually something that I had to deal with about a week ago. And so one of the last things that's great about containerization is it creates an image. And this is a static image that already has, like I said, it has everything in it, your operating system and the version of it, any dependencies like ImageMagick, or any type of binary that you need to run your application or perform some type of action for your application code itself, all of your application's dependencies. And so now we can use static analysis and check these images for vulnerabilities. So if you're using, if your Docker image is from, CoreOS version XY, you can check in a vulnerabilities database to see if that version has any type of vulnerability, and then you can update your image. So it adds another layer of security. Because if we're just running, CoreOS on an EC2 instance or some VM or something like that, then we have to check these things manually for vulnerabilities. But this gives us a way to automate it as part of our build process, which is always better. So one of the services that will actually audit containers for you is called AQUA. And so speaking of CoreOS, it's actually made by a team for CoreOS. And so they do a lot more than just the checks, right? So AQUA, you can actually build, store, and distribute your containers. It's almost like a private Docker registry, but it does a lot more for you. Whereas you're doing all the building locally and stuff like that, you can actually just push your Docker file, or in this case, link it to a GitHub repository. And when you make a change for master, it will read that, build your image for you, or during a pull request, and store it for you. But you can, as part of that, add to check for these vulnerability checks, and it will alert you if there's an issue found in any of the software in your Docker image, which is really fantastic. If you don't want to use a SaaS solution, there's also Claire, which is actually what's powering this vulnerabilities check for AQUA.io, and it is open source. So you can just integrate this yourself as part of your build process if you have concerns about things being behind the firewall and being, on internal networks. This one is AQUA PEEKR. Now they say it's a free SaaS scanner for container images. I don't have any experience with them personally. I've not heard anything bad, or really good, just that they are. But it's worth investigating. I always like to present options and the fact that it's a free solution. So I would just test first with things that you don't really care about. I don't think I would hook up my private repositories to it just yet. So the next thing we're going to talk about is securing dependencies. So we know how to get our runtime tightly wrapped up, but there's still other ways for vulnerabilities to get in, right? So we can lock down the environment that our app is running in, but we're still pulling in dependencies. If it's an API, we're still taking in requests. If it's a worker, maybe we're taking messages off a queue, or maybe we're reading something from a database that other applications are updating. The possibilities are endless. But point being is that dependencies is another way where you can have security holes. So when we talk about security, we don't just mean threats, right? It doesn't just mean a hacker. Remember that part of security is building confidence, people building confidence in your systems that you're building, basically much like a security blanket, right? We want stakeholders to feel comfy and warm when they think about the applications we provide them. And so part of that is securing our dependencies. Now, part of this is from vulnerabilities and threats, but it goes actually much deeper than that. So the first way to secure dependencies, which we actually talked about in code discovery a little bit, is by whitelisting and blacklisting modules. So blacklisting modules is basically we allow the use of any public module except the ones on the list. So maybe we have, a known list of NPM modules that are pretty shady, so we don't want them installed. This is one way to solve that. Now, I'm a much bigger fan of whitelisting, which is basically allow use of only the public modules on the list. So you can provide a nice, concise list of the modules that are available to developers. And, this can always be updated. This can be, an ongoing process and would require some work, right? So you'd have to vet these, make sure that the modules you're using pass any type of regulation or security checks that are required by your company. And then in which case, you could add it to your whitelist. So as I said, whitelisting and blacklisting modules is great for meeting audit and legal obligations. And then a final note on that is that it requires a private registry. So you can't just whitelist and blacklist from NPM. So you have to kind of mirror that public registry and then set in the configuration for your private repo which modules you want to be whitelisted or blacklisted. And as a matter of fact, so I forgot that I actually had some of these links. So I'm going to drop them into the chat because I forgot to share them with you as we were going. I apologize for that. So bear with me 1 second as we get these all caught up. And this is so you can investigate these services and these things that I'm sharing with you on your own in free time and form your own opinions about them. You might find other solutions that you like or don't like, but this will just make sure that you have all the info you need when you're talking about securing your environment. We are just about caught up. Here we go. Cool. So here is actually the docs for mirroring the public registry from NPM. So they actually talk about this, how to do this and how to whitelist and blacklist modules. So there's a great resource for that. So the next thing that I want to talk about And another great way to help keep your dependencies in check is what's called the Node Security Project, or NSP for short. So much like Ruby or PHP or pretty much any language that has some sort of dependency manager and a pretty robust ecosystem of open source software, they generally have some form of security committee that is responsible for keeping a database of known vulnerabilities and making that available to the public. And Node is no different. And there is the, I don't think I had this one open, the Node Security Project. Let me go ahead and find it. Here we go. Oh, Node Security Platform. Did they change this? I guess it's Node Security Platform, not Node Security. Okay, all right. So it is the same thing, but basically you can read this documentation here for the project, and it will basically walk through what it is and what it does. You can also read the vulnerabilities in the database. It has all that information for you. So yeah, so some of the things that they do is they keep a database of all known node module vulnerabilities. They offer a CLI tool, again, for easy CI/CD integration. So you can actually run this check against your dependencies during your build process. And it's maintained by the community and by the best node security experts in the industry. So I don't know if you guys are familiar with Adam Baldwin, but I would suggest giving him a Google and a follow on Twitter. He's a very wise guy when it comes to node security, and I believe he's still on the ANDYET team at ANDYET. I can't remember though. That Node Security Project is pretty much like starting to go its own direction. But yeah, I would definitely recommend giving him a look. So the next layer of security that we can add to our dependencies is the fact that if anybody's familiar with node versioning, you know that when you install a package, even when you save it, unless you're saving the exact package, you can actually get what's called dependency regression, where a dependency introduces a breaking change, but it's still within your accepted SEMVAR range. And you go to release your app, and all of a sudden, because you're pulling fresh from NPM, when you deploy with Heroku or whatever, et cetera, there's been a change even between the time you build and deploy. This can happen. I've seen this happen. And your entire application goes down, production goes down because dependency made a change that you were unaware of. And it doesn't even have to be your main dependency. So let's say you save exact Express, but then Express is using dependencies and they have open dependency ranges and they're not using exact versions. Then they can upgrade your dependencies, right? And so there's something in there could be incompatible. Maybe it's incompatible with the version of Node you're running. But point being is if you're pulling dependencies into your application when you're trying to start it and run it for production, you don't know what you're getting. So there's a couple ways that we can mitigate and then eliminate this problem. So one of the ways to mitigate the problem is to use npm SHRINKWRAP. So, oops, I went to two at one time. Okay, so right, so that part, npm SHRINKWRAP will help you prevent dependency regression alone. So what it does is it reads your dependencies and their dependencies, and it builds you a nice little file that npm install will then read from. So here's a fun fact about npm SHRINKWRAP real quick. If you have a SHRINKWRAP file defined, aside from getting the exact versions of dependencies you want, when npm, the command line application, sees that you have a SHRINKWRAP, it won't pull all the metadata down for each package because it doesn't need it. It knows exactly what version to pull. So instead of having to do all of that version wrangling while it's trying to install, it does it. So just using this alone will actually speed up your builds. because you'll be making way less requests to NPM, and NPM is doing less work to decide what version of a dependency to go get. Here, and I will share this link as well. So SHRINKWRAP will help that, but now I want to talk about a tool called SHRINKPACK. So SHRINKPACK does really two things, right? So it localizes the tarballs of your dependencies. So a quick side note, this will greatly speed up builds as well, even more than SHRINKWRAP, and we'll talk about why here in a second. So there's been this huge debate about a lot of people of whether SHRINKWRAP is enough, and then whether or not you should just commit your node modules directory to make sure you're getting what you expect down to the line. Now, this is a horrible solution for the fact that every time you add a module, it could add hundreds of files. And so you end up with these commits and branches that, you know, there's 3 lines of changes, but you add 750 files because you added a dependency. So what SHRINKPACK does is it says, all right, we're going to do a little bit different. So what we're going to do is we're going to pull down the tarred version, the bundled up version, and we're just going to put that into a folder and just save that. So instead of expanding it out into the folder and then committing hundreds of files for each dependency, you just end up with a single new file added. And so what that looks like is if we come up here and we open this node SHRINKWRAP directory, you can see these tar files for all of the dependencies for this application. And so now these are committed. And so what it does is it overwrites your npm SHRINKWRAP file and says, hey, forget npm. I have the tar at a local path right here. Just use this. So now from then on, from each time when you npm install, you're not even going to npm. You're actually just untarring this tar file that you have here and moving it into node modules. So number one, this speeds up build because there's 0 network traffic. Number 2, it prevents dependency regression because all of the dependencies are bundled up with these. So you don't have to concern yourself with dependencies being updated without your things. And so then, so you can see, so I updated my dependencies, and you know, we only have one change in here, right? Like all these were added in the beginning. In there. So when I made this update dependencies, I didn't get a 750 file commit. I just got one addition, one file addition. So it's a much more reasonable way to manage internalizing these dependencies. So I definitely recommend giving that a strong perusing. Sorry. Yeah, and so, you know, this greatly speeds up builds as well. Right now it's localized. So another fun fact, containerization can also help you prevent this problem. At Major League Soccer, part of our development build, it pulls down all of our dependencies, builds the application if there's a build step, and then pushes that container to a repository. Now, if that container, and that also gets deployed to staging. So if that container passes QA, right, for whatever change was made to it, we then tag that container as production. And so then all we do to release to production is pull that same container and release it just with different environment variables, our production settings instead of our staging settings. So because we pull in the dependencies during the build now in the container, so we don't have to fetch them when we go to production, right? They're already just sitting nice and neat for us. That's why I love containerization. It gives you your entire application, including dependencies, all wrapped up. So I don't know if anybody knows about the left pad scandal, you know, or like a left pad gate, whatever you would like to call it, but essentially half of the applications that were running on Node were basically brought down by somebody just removing the smallest Node module from NPM. So it brought down React, it brought down Babel, it brought down all these things, and we were completely unaffected. I can still go back and pull any version of my application and run it because I have leftpad. It's wrapped up in my container. It's there. I don't need to get it from NPM. So that is a great example of when everybody was freaking out and everything was down, we were just humming along. And so here again, so here it is again, SHRINKPACK. You know, it's a fantastic tool. I believe I also, yes, have the link for that as well. So it's very easy to implement. You know, you just run SHRINKWRAP and then you run SHRINKPACK and you're done. So it's very easy to integrate into your build. As a matter of fact, if we come here to the package JSON and we take a look at scripts, we're going to see package. And if we look at that, so there's this fixed shrink-wrap thing. I won't get into that now, but if you want to jump on Git or chat for this repo, I'd be glad to explain it. But anyway, you see, we just npm shrink-wrap. I'm including my dev dependencies. And then I'm running this to fix shrink-wrap. This gets rid of any optional dependencies, like certain ones that might be OS specific or something like that. They tend to break SHRINKPACK because if I'm on Mac and I pull a Mac specific version of a library and then I SHRINKPACK it and you're on Windows, that could break it. So that's what the gist of the shrink-wrap is doing, but I would explain it more if anybody wanted to know. As you can see, it's super easy, right? You just call SHRINKPACK. So if you just imagine leaving out this extra command, you just npm shrink-wrap and SHRINKPACK, and you're done. And that works for most services. I just happen to be using a package that doesn't play nice across the operating system. So we've made it through securing our runtime. We've made it through securing our dependencies. And it's finally time to secure our applications. So, you know, we're looking good now when dealing with outside factors and things that, you know, we can't implement ourselves and how to protect those things. But now we're going to look at how to protect the things that we are implementing ourselves. And so one of the very first things, obviously, that comes to mind when you're protecting an application is authentication. And so what authentication really is we're verifying the identity of a user or client. And really that's it. That's the only true security that it gives you. And technically, if you get somebody's information, like we're not even verifying, right? Like we're not at retina scanning yet and all that fun stuff. And anyway, somebody would figure out how to hack it or spoof it. But this is all authentication gives us. We just know we're dealing with a particular person. Realistically, in an enterprise world especially, you should support like JSON Web Token headers as well as basic authentication. In an enterprise setting, a lot of times that you'll find you'll be integrating with systems that may not be as up to date on development practices as you are, or people need to just write quick one-off scripts to hit an endpoint to get particular data, maybe for some like business visualization, et cetera, et cetera. Point being is if you have a very complicated authentication process and don't support something like basic auth, you can end up causing yourself a lot of headache down the road. Now, I'm not going to get too deep into it today, but if you do support basic auth, because it's harder to track because you just allow them to send like a username and password, you can do things to set rate limiting, like certain people can only use basic auth X amount of times per month. And when they hit their quota, you return them like a quota exceeded error. But really, JSON Web Tokens are a great way to transport information, and it's a very secure way of doing it. So I do recommend JSON Web Tokens, and we'll talk a little bit about them more coming up in a second, but I am also going to provide tons of resources about them because really we could do an entire talk just on that alone. So just like a quick recap of what exactly that is, a JSON Web Token is basically a method for representing data really between two parties. It's a way for a client and a server to say, oh, hey, like you do have the other part of my token, and the data that you contain within you is secure and safe. It's reliable. It came from me. And so JSON Web Tokens, the reason why I'm stressing them is because we're really moving into a world where cross-origin is like the norm, right? So it used to be this wasn't as big of a concern because you were always on your own origin. So, you could just send, username and password and pretty much be done with it. But it's just things are getting more complicated. Clients are becoming more decoupled, and they need a little bit more information about a person normally when they authenticate. And JSON Web Token does two things. It provides a safe and secure way to do that. But it also provides you ways to get this information without having to make extra requests, right? So it cuts down on the request rate. So jwt.io is a fantastic site. They even have a debugger that lets you play with JSON Web Tokens and test them out, setting them into, verified and unverified states, so you can try and spoof it and play with it, see what it's like when you add data to it, et cetera, et cetera. And so I have the website here. And so this is actually a site that's maintained by a company called AUTHO. And I really like them. They have a great mindset when it comes to security for web applications. And so I actually also have a link here to one of their articles on getting started with JSON Web Tokens. This is the article I read when I was first starting to read about them. It's really good stuff. And I would also just recommend like reading their blog. They have a lot more good. They have a lot more information of high quality. So I would definitely give that blog a read, especially if you're interested more in learning about authentication and JSON Web Tokens. So this brings us to the second part of securing our applications from a authentication and a permission standpoint. So we've already said that really authentication just verifies a user or a client. Now, that's like kind of like having the password to an apartment building, right? Like that gets you into that first door, but you can't just start going and opening all of your neighbors' doors, right? You need a particular key, and that key has to fit a lock. So you can think of authorization a lot like that, right? So authorization, we verify the permission of an action by a user or client. And so then we can think of a particular key that allows us to open certain doors as a scope, right? So we use scopes to define permissions. So if you have a scope, that means you have the ability to perform a particular action. We use roles on a user to help group these scopes to make them easier to deal with. So if we take a look here, this is just the scopes file for the Enterprise Web Service API. So you can see here that we have these groups, right? So we have user, we have admin, and we have super. And then we have a grouping of scopes underneath them. So if we actually come here, this is a migration file. This is actually responsible for creating the user table in our database. And you can see here that we are accepting the values of user, admin, and super. So if we come back, we see this direct correlation between a user role and scopes. So this is how we're able to make that connection between roles and scopes, right? A user has a role is assigned scopes, and scopes are set on endpoints for our fine-grained control. So a scope is essentially the lock, and if you have the proper key for that lock, then you are allowed entry. And so what that looks like is here we have this is route configurations. This is Happy. I'm using Happy.js. Route configurations look pretty much the same in a lot of languages, Express, stuff like that. So basically, there'll be a config object that represents an endpoint or a handler. And you can see that we have auth and we have scope. So if somebody wants to make a put request to the current user's current, they have to either have the user's write scope, which like a super has, right? A super can write to any user, or they have to have the user's write current. And so whoever is logged in as the current user will have that scope. So you can see that, you know, we can offer as fine or loose grain control as we want. And, you know, you can get like, you know, way more fine grain than this. This is just you know, an example of what you can do with that. But so now we not only have two ways to authenticate, right? We also have finer grain controls on a per user basis, or per role basis, I should say. And this allows us to break things down very finely, right? You might have a role that's guest, and a guest is only able to read things, right? And you know, they're not allowed to make updates or do certain things. They're only, you know, they're only allowed to view a certain, you know, page or particular thing. So the next step in securing your applications is we have to validate the data that's being given to us. So whether this is we're a server and we're getting a form, you know, or any type of payload from an API call, or we're a client and we're getting data back from some server or third-party service, right? Like data validation is very important. So we're really going to focus on the server aspect of it today, but there's nothing stopping you from doing this data validation in your client side. As a matter of fact, I'm going to show you an example that uses a library called Joy, and I use it both on the server and the client. We'll talk a bit more about that in a second. So data validation, it prevents dirty data from entering your system. That's the #1 benefit. However, if we're setting it up properly and using good schemas, we also get some added benefits. It allows you to define schemas that documentation engines can read, and we're gonna take a look at this in a second. And then also it provides in-code documentation. So if we get a better example of that, what that really means is, so I'm using a library called Joy. And so here I'm going to send a link to this. So all it does is allow you to define allowed values for particular properties or, you know, objects, things like that. And so here we have a user post payload. All right. And so we're saying the email is going to be a string. It's going to be an email, and it's required. You know, and then we have certain other things, you know, that we're also looking for, right? So password is required, role, you know, this should probably be required, but you get the point. So now what we do is we use this Joy validation in our routes. And so this is the user post payload. So if we come back here and we find our post, so we're telling Happy validate the payload and use the user post payload. So now what's going to happen is this request is going to come in, and Happy is going to take a look at the parameters that came with it, and it's going to say, it's going to read our validation. It's going to say email. Okay, it is a string. Okay, it is an email, and it's here. We're good to go. Password, it's a string. It's any of these accepted characters. Oh, the password is 800 characters long. Error, and it will send you back with a message to, it tells you exactly what property had the problem and what the error is. And you get this for free. You just write these schemas, you drop them on your routes, and now you're getting really good data validation and data scrubbing before it even gets in your application. And so then you can feel a little bit more secure about working with this data. And then as you know, a benefit, you tie it into something like this. It's called Happy Swagger. And so Swagger is an open API specification documentation generator. They actually do a lot more than that. You know, but one of the best things that they do is they have a bunch of different services to automatically generate documentation. So I didn't write any line of code, and if we take a look here, we can see that it's reading, telling me all of my endpoints, API authenticate, and it's saying a data type example, an email, and a password, and it's reading that from my Joy validations. So I didn't write that. It's actually pulling the Joy validations off of the endpoint and then saying it. So see, we see email, password, role, created at, updated, deleted at. And these are things that you would otherwise have to define your own in like each route options for Swagger. So now I have living documentation down to the parameter types for my entire API, and I haven't written a single line of code. So these are the type of things, like by doing these and putting these processes in place, it might take you a few minutes up front, but you're not just getting security, right? Because you have so many ways to identify and you're actually, you know, putting very strict rules around what kind of data comes into your API or service, you can do that. So here's the flip side. I can take the same validation. If I wanted to, let's find this. I could take this same object right here, include it in the client, and have a form that has an email, a password, and a role. And I can actually validate the data from that form with this same schema. And if it fails client side, I don't even have to send it to the server. And so now if I update this schema, it will be updated for the client form and for the backend. And if you really wanted to be stringent, you could also add this same validation to models. I could add this to the user model, and on before save and on before update. I could call the same validation again to make sure that that data didn't get munged between my endpoint and between hitting the model at the database layer, right? So, you know, it doesn't just, data validation doesn't just provide you know, the benefit of preventing dirty data coming in. It can also prevent dirty data from even leaving the client, or from data that's maybe been malformed through some type of process in your application, you know, or having some type of incorrect value. It can prevent that from getting written to the database. So it's definitely a very powerful feature. And then again, so just talking about Swagger docs from Joy schemas, you know, you can see that the API users took, you know, accepts or has multiple properties defined on it. And then these are what they are. So the next part of securing your system is talking about HTTPS. So when we send things over the internet, you know, really it's just small packets of data that are just traveling any which number of ways, right? All which types of ways: underground, through space, you know, satellites, back down to cell towers, wherever, however it's getting from A to B. But it's just open. If you're just over HTTP protocol, you're just sending this data open. And so what this allows is for people at intermediate points between you and your endpoint is to set up things like packet sniffers or man-in-the-middle attacks. And while these things seem kind of like, you know, maybe from the movie Hackers or something like that, this is a legitimate issue. And it happens to companies all the time. And companies, if hackers are smart enough to start figuring out entry endpoints into your infrastructure, although they might not be able to gain entry into it, they can start sniffing all the data coming in, looking for ways to get in. Or maybe attaching something malicious to said data that is coming in from a valid client, right? And so these are all very possible things over HTTP. So HTTPS is basically just adding encryption to this data before it's in flight, and then decrypting on the other end. So encrypts data sent over the internet, right? So we've talked about that, and or it could be via any channel, right? Like this could be internal, intranet, you know, anything. So it helps prevent the packet sniffing and man-in-the-middle attacks because the data is encrypted, and without having, you know, either the key or the, you know, or the cert for that SSL, or now it's TLS, for that TLS encryption, they're not going to be able to get much from that. Now, another note is that generally you terminate HTTPS at the CDN layer. That's like a general rule of thumb. The reason why is because encrypting and decrypting takes time, right? So although it provides better security, it adds latency to your requests. And if you were in a system, a distributed system, where an incoming request might be dependent upon, you know, 8 to 10 more internal requests, it actually adds up enough to maybe delay requests an entire second or more. So it's a trade-off, you know, so you have to decide how secure is this particular thing? And there's nothing stopping you from having HTTPS protocols, maybe for all of your billing services and all this stuff like that that are internal, and then maybe you lighten up on your your mailing service and some other things. However, that can create issues with the confused deputy attack. And so what that does is people will try and gain entry to less secure systems and trick them into accessing more secure systems that they have the proper authentication for. So basically, point being is like, don't build applications because someone's trying to break it. So the last thing that we're going to talk about for securing an application is actually encrypting data. And this is internal data that your application is storing. So you should always encrypt sensitive information. And this is regardless of anything else, right? Passwords, social security numbers, credit card numbers, any type of personal information that can seriously damage a person or an entity, or just can have really bad effects, should always be encrypted. And do some research on encryption best practices. There are multiple types of encryption. You're going to hear things like SHA-1 and MD5 and salt generations and like all this stuff. It's an area that can be a bit deep and not that deep. I believe Auth0 has some good stuff about it, but there's enough to get just a web developer's needed level of knowledge around encrypting data, but it is an important subject, so I do recommend that you spend some time to do it. And then make sure your encryption keys are secret. So this sounds silly, but a lot of times people will commit their configuration with their keys and stuff like that, and that's not secure. It's pretty vulnerable. If you think about it like this, so if I commit a secret, right, I might have a private GitHub repository, and GitHub might not ever get hacked, but then again, it might, and someone might get access to your repository. Or better yet, you use Circle CI to build, or you use Heroku to deploy. Fun fact: every time that they deploy for you, they actually do a Git checkout. So now maybe they blow it away. Maybe they keep a reference to that checkout so you can roll back your application. I don't know. But the point being is, now your key is on Heroku. Now your key is on Circle CI. Now you're using AQUA to build your Docker containers. Now your security key is on AQUA.io. So if any of these third-party services get hacked, you just got hacked. All right, so it's make sure you keep them secret. They should be environment variables or some type of private key value store like console, something like that. So that really wraps up this. Actually, real quick before QA, I did have a couple more links that I just wanted to share before we wrap this up. Oh, and so here's an example of encrypting. So before I create or before I update, I actually check to see, get the model, and I'm actually calling this async hash, which is an abstraction, but really boils down to this hash method right here. And so you can see that we are, encrypting it, and then we encrypt the password. So like we generate a custom salt, and then we encrypt the password. So you always want to add like these layers of protection. And this is in the plugins hasher plugin. So if you want to look at that, that's where you can actually see that code. And then I believe, oh, this was NSP, yeah. Oops. So at this time, I'm going to open the floor for Q&A. So if anybody has any questions, feel free to either drop it in questions and topics or in the chat. And then also, if you guys have a moment and you want to, you can just go ahead and fill out that third poll and let me know how you thought this webinar went. I know this was a bit more meaty material, but it's pretty important stuff. There's another service called sync.io. Yes, I actually meant to reference that. So sync.io, and Joanne shared the link. Thank you, Joanne. Is basically the node security project as a service. So much like there was AQUA IO and then Claire, you could use AQUA, which is the external service, and they handle the work for you. Or you could use Claire and do the checks yourself during your own build process. Sync IO is much like that. So Sync will do the node security checks for you, and you can integrate it with GitHub, and it will like fail your PRs if it finds vulnerabilities. Or you can actually run it yourself. So I actually have node security, an audit running in the, actually, let me find the build for that. You can take a look. So I have it running during this build process. So where do I have this? Circle CI, right? Yeah. Go here. Log in. All right, awesome enterprise web service, cool. So if we come down here, Docker info. So we're running this Docker, KCample, awesome enterprise, run audit. So I actually just left this here so the build will complete, but there's actual vulnerabilities here. And so I left them in so that we could see what they look like. And so this is what the NSP project will do. So it will run its check. And then it will give you this information and say, oh, negotiator has a known vulnerability. Here we go. A DOS attacks due to excessively large WebSocket message, and the WS library has that vulnerability. So you can see, and I just checked this and updated some of these a couple weeks ago. So all of these, I just ran this build, I believe today. I made some minor changes, and so there's already 7 new vulnerabilities discovered. 7 new vulnerabilities in a couple weeks. So you can start to see just how fragile and how exposed you really are. So I'm going to drop the link to this, and it should be public because it's a public project. So you can just go through the build history, take a look at the builds, and do some of that. Let me know if that's not available, if anybody cannot see that. I'm not sure if that is public, but it's a public repo, so it should be. Okay, oops, sorry, keep hitting that extra slide. All right, so are there any other questions or comments? I'm going to give a minute for that to settle. All right, cool. I guess there's a bit heavy content, but very useful information. So this was part 3 of the 4-part series, securing your environment. So it looks like tomorrow is going to be deploying with Docker. So this will also be another meaty one. I'm not going to get too deep into the depths of getting started with Docker. This is going to more show how to use Docker to accentuate a build and deploy process. So it will cover basically showing you how to get security from it, keep dependencies locked down, and do that. And as a prepper, I'm using Docker and that awesome enterprise web service. If you go to the wiki, it talks about how that project is built to every piece. As a matter of fact, if we come over here and we jump to the wiki, you'll see that there's quite a few pages, right? So if you want, you can go through in order, and this kind of goes through what you would need to know in order, or you can jump around and look. And so a lot of the things that I'm talking about are already documented. So you can just come here, jump around and check, and it points to places in the code where you can see those things in place, and it tells you how to pretty much do everything, has all the NPM run scripts included. So I would definitely give it a look. Check out the wiki. Yeah. All right. And on that note, I'm also going to be speaking at O'Reilly Software Architecture Conference. And I would love if you guys would come and see me. I'll be speaking in November in San Francisco, California. I believe the early bird tickets are still on sale. Oh, real quick, we have a comment. Okay. Oh, cool. A node security event. Awesome. Thank you for sharing that link. I'm going to check that out as well, too. Very cool. Yeah, so that is it. I'm So glad to have shared this with you guys. I hope you guys got a lot of useful information from this. It's definitely a great jumping off point and gives you some things to talk about. Also, the slides are available. They're on SlideShare. This video is available, so come back, check it out. And now that you've started to get an introduction into the actual repository, I suggest going through the wiki. Try and set that project up and get it running so you can mess with the scope and tokens and documentation and all that stuff. You can run that project with or without Docker. It has documentation for both. All right, guys, and that is it. So I'm going to wrap it up and close this out. You have a great evening, and thanks for joining.